All right. There we go. Good now? Okay. So I have a router, and I've got an upstream connection, 1,000 bytes. I transmit 2,000 bytes. The router breaks it down into two smaller chunks, transmit them one at a time across, and then when it reaches the router on the other side, it doesn't put them back together. It makes it all the way to your workstation or your server or whatever the final destination of the packet is. It's responsible for putting that back together. So hackers figured out that different operating systems treat these things differently, and so they could use this to evade packets. So let's pretend these are bytes, right? They're actually going to be 8-byte chunks that it transmits. Let's pretend each of these are bytes. And I want to transmit, we'll say 12 bytes across a network. What an attacker can do is he can send 3 bytes with an offset, right? So the offset is each chunk is broken down, and so the endpoint, when it puts them back together, it's going to get these pieces of a puzzle, and the offset says, okay, put this bit here and put this bit here, so that it knows how to put these things back into the right order. So what the attacker says is, all right, well, we'll transmit these 3 bytes here in position 1 at an offset of 0. We'll transmit these packets at an offset of 5, these 2 bytes here, and then we'll transmit these 3 bytes at an offset of position 7, and then these 4 bytes at an offset of position 2, and these 5, and so forth. All right, so if they transmit these packets, then when the receiver puts them back together, they've got to make some choices, right? What byte is going to end up in this first spot? Well, 1. Of these 6 fragments, is what they're called, 6 fragments, only 1 of those fragments is claiming that they have a byte for position 1. But in position 2, there's actually 2 that are saying, I've got a byte for you. I've got some data for that position. So who's going to win, right? The operating system, like Windows, could say, all right, I'm going to take whoever arrived first. Or the operating system like Cisco could say, I'm going to take whoever arrived last. In which case, the 2 different operating systems have a different view of the world, right? They're going to see different packets. And so if your intrusion detection system, the things that's looking for attacks, sees these packets in 4 and is saying, are there attacks here? But the endpoint that's actually going to process the packet sees what's in packet 2, well then your IDS says, oh, there's nothing evil here, but the endpoint says there's evil here, and so this is one of the ways that this has been a problem. But so this has been known for years. Fragment overlap attacks have been known for years, and the best way to solve this, by the way, is to put something in the front of your network that reassembles all of these packets and just puts out a unique stream into your internal network. Okay, but the thing is that even today, right, this can be a problem because, well, although what IDSs will also do, your intrusion detection systems, they will reassemble all these packets in all of these different flavors so that they can see every view of the world, and they'll inspect all of the views of the world. So they'll say, there's definitely attack here. Right? But we use Wireshark to, once we get that alert, we're going to pull it up in Wireshark, and we're going to do it. And which one of these, what does Wireshark do? Wireshark has one view of the world, and it's not selectable, and it's hard-coded into the product. So this is what the different operating systems would see. So Windows, Sun, Mac OS, they would all see this stream of packets. The Cisco-based products see this. Linux operating systems see this, and so forth. There's some asterisks next to these because some of the operating systems have changed their behavior in recent years as to the way they process these things. But the problem is that Wireshark is hard-coded, that it will only show you this frame, which, so when you're analyzing your packets in Wireshark, right, your IDS just said, hey, there's an attack that's going on in your network against a Windows system, and you say, analyst, I want to understand what's going on. You download the packets, you open them up in Wireshark. Wireshark isn't showing you what your Windows system saw, right? Wireshark is showing you what AIX operating systems, FreeBSD, HBUX, and VMS, what those operating systems saw. So those operating systems on your network are completely safe, right? But if you're using, I don't know, Mac or Windows or Linux or Cisco, that's not what you're seeing when you're looking at it in Wireshark. So what Reassembler does, 1 packet in, 6 packets out, right? So it will write those 6 PCAPs so you can look at each of the different packets in each of their reassembled format. The other thing it does is it scans networks, and it'll tell you what a remote network is using. So if, like me, you're on the offensive side of the house and your customer, you want to avoid some intrusion detection systems on your customer's network, then I can use Reassembler to scan a given company and say, hey, reach out to this company and fragment some packets and overlap them in different ways and tell me which of those different reassembly policies that we saw is it being used. And so here we can see that I scan Facebook, comes back and says, oh, they're using the Linux policy. Here, Amazon using the BSD policy. And here when I ask for Google, it's saying, yeah, sorry, they're doing something. They've written their own TCP stack there that is not using any of the known reassembly policies. So it'll scan those things. So based upon that, I can come back to here. I can then look and see how would I overlap my fragments. And that's Reassembler. And again, you can get that for free on my website, or GitHub's website. I don't own that one yet, so I don't think I ever will. All right, so domain stats is a third tool that you can also get on my GitHub page. And what domain stats is intended to do is to supplement your internal intrusion detection systems. So you have SoftElk, Zeek, you have all of these different tools that you've got that are monitoring your networks, or maybe you have commercial security event management platforms that are collecting up all of these logs for these other things. The idea of domain stats is it's going to be another server that you stand up on your network, and you'll integrate it in with any of these other products. And every time it sees a domain on your network, a request for a host name, Google, Facebook, whatever, it'll send off that request to domain stats. Domain stats will look it up, come up with some statistics on it, and then give you back some information that you can then integrate in with your normal alerting. It's looking for DGAs. DGAs are dynamically generate. You have a dynamic generation algorithm that is choosing host names randomly, right? If I'm an attacker and I want to set up a command and control network, right, I'm not going to buy mybotnet.com and have all of my bots report back to mybotnet.com, because the FBI is going to come and take down mybotnet.com, and then I've lost control of all of my bots. Right? So instead, what I'm going to do is I'm going to program all of the bots to have multiple names that they can choose and then go back to that same location. So if they take down my botnet, we'll all meet at this next location, this new random name that they're going to choose. It's important that my bots don't randomly and accidentally choose google.com, right? Because, well, I can't go buy that host name. So these names tend to be very random looking, right? And they're made up of numbers. They look different. They don't look like domains that we would ever choose, right? Because if they did, then somebody might have chosen it, and well, then we can't purchase it. So these DGO domains, they look different. Here you see a couple of examples of the kind of names that we see with command and control channels, malware, payload droppers, and other things that are associated with malware. These also appear in certificate names associated with malware, so the SSL certificates and things like that. Actually, these, I'm sure nobody recognizes these, but these were disclosed by SANS last year. See, SANS got popped with a phishing attack sometime last year, and then they did several broadcasts where they disclosed all the information. They said here's the domains that the attackers were using, the malware that they use, and they went through a full disclosure showing everything that happened, and it turned out to be pretty good. So here's some actual domains that were used in this track, and you can see that they don't look like domains that we would ever type, right? They're random looking. Well, so one of the things that domain stats does is it identifies whether or not these are random by using what I call the Wheel of Fortune method, right? I used to skip school a lot growing up and pretend to be sick and then watch Wheel of Fortune, right? And so I know that if Vanna just turned the letter Q, that the letter that's going to be after that is the letter U, right? I know if it ends in the letter R, that there's a pretty good chance that the letter E is going to come before that. And so I can measure the probability of certain character pairs and see, well, do those pairs, is it likely that in, a host name, I'm going to have a G followed by an O, or an O followed by an O, or an O followed by a G, right? What's the probability of each of those character pairs? And then I can measure them. So I built a table called a frequency table that comes with this tool called Freak, and it just measures these probabilities of these characters. So here I'm measuring google.com, and it gives me back some scores of 6 and 4. YouTube, I get back 10 and 6. And so that's what the scores look like for if it's probably not a malicious domain. But then when I start putting in some random looking characters here that we would see, and these are all legitimate malware domains that I just grabbed off of a website that says, here's some known bad actors on the internet. Just plug those in, and you can see the scores drop way down, right? So 2s, 4s, 3s. Right? And so generally speaking, if you get below a 5 on your first score, below a 4 on the second one, then it's likely a DGA, or a dynamically generated algorithm. So this will identify those as one of the things that domain stats does. The other thing it does is it looks at the creation date of the domain. When was the domain registered? And here we're looking for what we call baby domains. So the other thing is, if I want to stand up a legitimate organization, a legitimate company, right, I might buy the domain, stand up the website with great intentions, and then it takes a year or two before you can actually get any customers to come to your website. So having a website that is only, I don't know, days old, weeks old, months old, and having lots of people know about it and go to it is, well, not that common. Things like google.com. Right? Google.com was registered in 1997. YouTube in 2005, right? The baby of the group here is Snapchat, and it is almost 10 years old now, that domain name. But if we look at some domains that are associated with malware, and specifically I'll look at the ones that were disclosed in that SANS phishing disclosure, the registrations are, well, recent. They actually disclosed this on 7/24, 2020 is the day of the attack. The registration date of this domain, 7/24, just hours before it was used in the phishing attempt, right? They purchased that domain and stood it up. So if I can take every host name that you give me, and I can look up when was this thing registered and determine is it a domain that's been around for a while, or is it a brand new domain, and identify those baby domains, then that's something that is useful to you. So that's what domain stats does, right? You stand it up, it acts like a web server, and then you'd send requests to your web server. So here I'm asking for google.com. I just got it running on my local host. Ask, hey, what's google.com? And I get back a JSON response, right? It's JSON response, so it's easily integrated into your event management platforms. It's got some alerts, and then it's got some things like the category. The category is always going to be, is it new or is it established? Established in this case means it's 2 years old, but that's tunable. You can whatever's established for you, but I think 2 years is probably a good number. The alerts, you can see here it's telling it this is your first contact, meaning that no one in your organization has ever looked up google.com before. All right, so this is a brand new system. I just stood this up for capturing these print screens, but you can imagine that over a number of months, right, at first everything is going to be a first contact, but once this system stabilizes and it learns what's normal for your organization, well, then it's got a list of the domains that you've gone to. And if you've never gone to this domain before, like you would for a phishing attempt or a command and control channel that just happened, then it's going to identify that as one of its alerts that's in the alert section. Here I'll get the categories established. Here you can see the frequency scores, and the rest of this is some of the detail, how it looked up this information. It is seen by Internet or Internet Storm Center, ISC. It is how it looked these things up. I can explain that in a little bit more detail later. But there we see the date that this thing was ever first seen on the internet, which is the registration date of google.com. There's that 1997 date again. And this is the first time it was ever seen by you, right? So the first time that your organization ever saw the domain. So we can take this stuff, we can integrate these in. Here you can see I go to runcode.ninja, an amazing website with lots of great CTF challenges. Looking forward to that coming back up soon. Runcode.ninja, I go there the first time, I get the your first contact. My next request to runcode.ninja, that your first contact alert goes away. So I can see when I go to a domain for the first time. So here's some lookups of those domains that were in that phishing disclosure. So had SANS been running this at the time, then this is what their analysts would have seen in their alerts. They would have seen an alert that says, hey, I want you to know that this is your first contact at a domain which has some suspect frequency scores. It looks like a DGA to me. You've never gone there before, and this is a brand new domain. So this is not a domain that's been on there. So 3 alerts there to give you a strong indicator of compromise. And then here's the second domain. You'll notice this one has low frequency scores. So the difference between suspect frequency scores and low is suspect says one of those 2 scores was below its threshold. Low means both of those scores were below their threshold, is what those mean. Okay. This tool is ready. Today you can download it. The name resolution is limited to really RDAP and me giving you, so when you download it, it'll preload the born on dates, what we'll call the date registration for for about the top 1 million domains. And then the rest it'll look up over RDAP. And RDAP has limited support for certain number of domains. So it doesn't do very well with like the country codes, like the .uk domains and things like that. It doesn't do very, actually there's no .uk. It doesn't do well for the country codes that are on, and looking those up. But those protocols will be added to the, when they add those countries to the RDAP support, then the tool will support it as well. There are some plans for having RDAP actually resolved through the SANS Internet Storm Center, and then have them actually look up with a paid service that goes directly to whois. And if we do that, that'll have an additional advantage in that you'll be able to get an alert that says, all right, of all the people that are running domain stats, you're the first person to ever look up this domain. So you could have, this is new to you, new to the web, and it's new to all of the domain stats users if we centralize that. But having that centralized log has been delayed for a while. I don't know when we'll get Internet Storm Center to host that for us. So where do you get this? Again, it's on my website. It's got Zeek integration scripts. So if you want to integrate this with Zeek, you can do it. It's got Docker scripts, so you can run this within a Docker, and all of these are there. So this is, all you have to do if you want to run in a Docker is just Docker build, and then point it at my GitHub page, and it'll build that Docker file for you, and you can run it in the Docker. There's some additional instructions on the website for getting it installed. It comes with some Elastic pipelines, so you can ingest this information into Security Onion, and you get some nice alerting out of Security Onion. So here you can see my suspect frequency scores, my low frequency scores. First contacts are all alerted through this Elastic pipeline. And here's another look at some more Security Onion. Doesn't it just make it so much prettier, right, than looking at a JSON response? So we can see over time the kind of domains that I'm getting. Okay. Another tool that you can download for free on my GitHub is called Apify. Apify, my goal here is just to save you 1 command a day, right? Whenever you're doing incident response or network monitoring and you see an alert, you see some domain that's on the network, right? We've all got some go-to commands, something that we do first to see, what's up with this domain? Where is this, right? Hopefully it's not a ping, right? Hopefully you're not just pinging the host to see, well, are they up? Because it's not our job to troubleshoot their network, right? But maybe you might look and see, well, where is this domain from? What's my route to them? Maybe a trace route information. Or look up the registration date of it, things like that that we wouldn't do with domains. So what Apify is well, it's just a web server that you can configure to run any one command for a domain that you give it, or an IP address that you give it. It'll run that command and then give you a JSON response so that you can incorporate that into your SEIM. So it looks kind of like this. It's got a configuration file where you give it the command you want to run, and then web info. This asterisk web info is going to be replaced by whatever it is that you put on the URL. Who's thinking command injection attacks? Right? All right, so whatever you put in the URL here, right, is going to be replaced with whois, and then that command will take the results. You can have it capture the information and run it through a regular expression. So it'll give you back just pieces of that information. So here you can see the kind of JSON response I'm using to get back just the creation date on this. So this is doing something very similar to what domain stats is doing for looking up that domain. And actually, there is a version of this. So you can either enable or disable command injection attacks. So if you were actually looking for a little website that was very hackable, right, where you could inject commands. So in here, instead of typing in a domain, you type in a command, and then it'll run it on your, instead of the command it's doing. You can enable or disable that in the configuration files. I have written it so that it should not be command injectable. Okay, I won't say it's not because, right? But if the libraries that are intended to protect against command injection actually work, then it would not be command injectable. Okay. It comes with several different configurations, but one of them that I found to be fun, at least on the networks I was monitoring with this, was monitoring tracebacks. Right. So let's say that I see an attacker come into my network. I got an IP address from an attacker. I want to know what is the infrastructure between me and the attacker, and then figure out which other IP addresses on my network share that same infrastructure. What other IP addresses are also associated with the attacker, right? So it might be that an attacker comes in, they could go through one path and another hacker, and if they go through, everything is the exact same path except for that last hop, right? The only thing that changes between them is that last hop. Well, then they have all of the same infrastructure. It's very likely that those attackers are on the same network, or at least in the same area. They're sharing a lot of internet infrastructure. So what if I just do a trace route for every IP address that I see on my network, or every hostnet? Well, the problem with that is if we look and see how long does it take to run a trace route to a network. Like let's just do a trace route and see, show me all the connections that between me and Google. Here, if I run that once, it takes 1 minute and 6 seconds to do that for Google. And so I want to do that for every IP address I see on my network as I see them. That sounds like that's a losing proposition. Well, can I make it faster? Well, there are some options you can pass the trace route. So -n says don't do DNS lookups of host names, just look up the IP address. You can use a -f to say, you know what, skip the first X number of hops. I know what my infrastructure looks like, so I don't need to trace route my internal router and then my internet service provider's router. I'm going to skip the first 5 hops, right? And then just start tracing from there to see what the network is. And the other thing I can do is, by default, trace route will map that same network 3 times. Right? It'll send 3 packets out to try and discover the network. So I'm going to reduce that to just 1 packet. Right? I'm only going to do it once. And so if I do that same thing, right, with Google, and I'm also going to do TCP port 80 as I do this. Right? Now I'm down to less than a second here in order to do that same trace route. So maybe that's a little more doable. There's all kinds of configuration changes that you've got inside of Apify, and did I drop the slide? Oh, so how effective is it? So this is what the API configuration looks like. I'm going to put in there traceroute -t 80, and then plug web info in there. I've got some regular expression options so I can parse out just the IP addresses of the infrastructure. And then when I use this Apify config, and then I ask for sans.org, I can just see, all right, hop 3 is this IP address, hop 4 is this IP address, hop 5 is this IP address. I get back a JSON response that I can incorporate in there. All right, so how effective could this be at looking at your network? All right, so I just took some IP addresses off of a list of known bad actors. And if you just looked at these IP addresses, 93, 174, 93, 0, 80, 82, 70, 0, 89, 247, 174, 0, would you say those are on the same network? Right? Would you immediately say, oh, those are the same attacker, I should worry about those? I don't think that just by looking at those IP addresses, you would think that they were coming from the same location. But here, I ran those through this, let it do its trace routes, and then here I'm actually dumping. I'm using a tool called dump cache that comes with Apify just to say dump what's in your database. I'm asking it to dump the JSON responses here and look for this one IP address that's in the list. And then show me -C1 says show me context, show me the line before it and the line after it. And so here you can see it's giving me the results for that IP address, the line before it, the line after it. And you can see that these have the exact same hops. The exact same infrastructure is shared there. Now it could be, at least they look like they do at this point. It could be that they have 20 hops on both of these networks, and that beyond 10, none of the routers are responding to it. So that's a possibility. But the fact that they have they probably don't have 20 hops, right? And the fact that they share 10 is some strong indicator that they're likely at least perhaps related. Maybe I should pivot my investigation. If 80.82 is attacking me, maybe I should pivot my investigation and then go look at this other IP address as well, okay? So that's Apify. So Apify comes with several pre-configured commands that you can run in the configuration tool. It can look up whois records, it can do the trace routes, it can do a full trace route, it can do a geo-IP lookup, so if you want to know what country is this IP address from, it'll do that and give you back the country of origin. And it can also query the Internet Storm Center's API for IP address threat intelligence information, and then you can just, again, it's a JSON response, so you can incorporate that into your SIM platforms. Okay. Another two tools I want to tell you about is SRUMDump and ESE to CSV. So what these tools are really focused on, I can't remember if I put a slide in. Yeah, so this slide here. You've gone to your task manager on your Windows systems before, and if on your task manager you got this app history, right? The app history tab. Have you ever looked at that app history tab? It's usually a bunch of useless information, right? It shows you over here the Metro application, all these applications that we don't use on our operating system are over here on the left, and then the statistics are all 0 because nobody uses those applications, right? So it doesn't seem like there's much useful data there, but actually, this app history, it doesn't just record the app history for these applications, it records the app history for every process that is running on your computer for whatever this date here at the top. Here it says resource usage from 10/10/2009. So when I made this print screen, that was 30 days of information, right? So this was done on November 9th. So 30 days worth of information it's keeping in that database. And it's not just those applications. This is every process that's on your system. So how do I get the information of every process that's run on my computer for the last 30 days out of the SRUM database? So I wrote these two tools called SRUMDump and ESE to CSV. Okay. SRUMDump was actually written with law enforcement in mind. The idea is I wanted to present you with a graphical user interface that is very simple to use, right? You just point and click and have it export everything to an Excel spreadsheet, and then you can do all of the additional analysis in an Excel spreadsheet. So it's really focused on ease of use. ESE to CSV is for the network admin who needs to pull the logs from every system. I don't know about you, but I've done some incident response work even in the last 3 months, right? Where I show up at the customer site and they've been compromised, and I'd say, hey, all right, let's start looking at some logs. And they look at you like, logs? What are these logs you speak of? Where would I find such logs? I'm like, well, hopefully you've turned on logging of some sorts, right? So still in many organizations, there's just an they're not capturing all the data they could. And even in organizations that do have logging, process level logging on every endpoint in the host, right? Unless you've got a good EDR that's really monitoring every single process, it's not common to find every process on every host logged. So ESE to CSV, I can use something like psexec or CAPE would be a better option to reach out to every host on the network and say, hey, give me a list of every process that's run on every host in the last 30 days and write all these things to a centralized share. And then I can take that centralized share and analyze every process for the last 30 days. It's intended to be powerful. So ESE to CSV's got a modular plug-in framework, so it doesn't just dump the SRUM. It can also dump like browser history, Edge browser history, or really anything that's in an ESE formatted database is what it's intended to be able to dump. Okay? So here's a look at the SRUM interface. You run it, it's got a nice graphical user interface. You have to reach out to the sru.db.dat file, which is in your Windows System 32. And then it also wants to know, like, where do you want to put the spreadsheet? And the spreadsheet has a template that comes with it, so if you only want to dump some information out of it, you can modify the template. And then it also wants to know where your registry files are used, because it does do things like look up the names of wireless networks and look up the names of users and things like that on the internet. So it'll ask for that information as well. If you don't know that information, if you run strum dump as an administrator, then when you try and access the srudb.dat, it says, hey, you're trying to access this, and it's locked by the operating system. So this is that file along with the registry file. You can't just browse out and select those. Actually, you can, and if you try and access those files, the operating system will let you copy them, but they actually are corrupt copies, right? You don't get complete access. So you do need to make a backup copy of those files first. If you run it as an administrator, it will, you can click this auto extract button, and it will use, it'll use the shadow copies that you have on your system to make a backup copy of these locked files so it's got that, and then it'll extract all the information, builds a nice spreadsheet. This is the kind of information you can get out of Strum. You can see that there's multiple tabs here. So I've got a network usage tab, an application resource usage tab, network connections, network push notification data, and the kind of information I get is, well, I ran this process. So at some point I had netcat running on, of course, I'm a SANS instructor, we had to mention netcat, right? So we got netcat running on this process. I can get the security identifier of this, and if you provided it with the registry file, it looks up and it'll tell you this is the user that's associated with that SID, so it'll give you the names of the SID. It'll tell you that netcat used the open Wi-Fi connection, so you have a wireless network named open Wi-Fi. It used that in when it was running, and it transmitted this much data across the network. Right? So that's a lot of detail that you have in Task Manager that looks like a table that's full of zeros. Right? So Strum has a lot of great information, and that's just the network usage tab. You can go to other tabs and see what the percentage of the battery was that was on the system, right? So the battery's fully charged, and I've talked to law enforcement that's used that when, in places where the person has said that their laptop was there at their house in the docking station the entire time, right? And that their laptop was never taken somewhere else where a crime was committed. But then they can look at the battery usage and they say, yeah, apparently that's not the case because your battery ran down to 10% and then it came back up to other things. So there's all kinds of useful data that's in there. Again, ESE to CSV is the command line version of this. It also has the ability to acquire locked files using the volume shadow copies. So if you are an administrator, you can use that -A option. You can list all of the tables that are in an ESE database. You can dump all the tables, or you can dump specific tables, so you don't have to dump everything. And it does have plugins, right? When I published this, I had visions of the entire internet community then sending me new plugins to plug in. Of course, it only has the 2 plugins that I've written at this point, which is it will dump the Strum, and it can dump your Edge browser history, which is the Spartan database. Okay, so you can combine this with ESE to CSV and PSExec or CAPE. And then run this on every process in your system, collect up all those processes essentially. The way you do that is you're going to stand up a share, right? And then you're going to specify that the output of ESE to CSV is going to be some centralized share, and it'll be written to that spot. The 7th tool I want to mention, and I think this is my last tool, is Where'd You Go? Okay, Where'd You Go is a laptop historical location tracker. This is actually a tool that we develop in the class that I've written, the SANS SEC 573. Right, we talk about how to write code in Python. And some of the things that we talk about in that class is how to access the Windows registry and how to talk to online websites and submit things to APIs to be able to get responses back. And so we combine those tools into, this is one of the tools that we write a large portion of in the course. So what ESE to CSV does is it will pull your wireless history from various locations on your system. It'll pull it from your registry, right? So we've all seen on our phones or our laptops, it recognizes when we're around a wireless network that we've been on before. That preferred network list of wireless networks is stored in your registry on a Windows system. So it will just go through all of those wireless networks. It will get the BSSID, which you can think of it as a MAC address, right, which is a unique identifier for the wireless access point. And it will submit that to online websites. It can do it through Google, and it can do it through Wiggle, and it can look up what the physical location of those wireless networks are. The other thing that is kept in the registry is the very first time that you connected to that, because when when you connect to it the first time, it creates a profile, a network profile, so I can get the data of that network profile. And then the last time you've connected, which is also there. So let's say you go on a business trip and you're in a location for a week. You arrive, you connect to the wireless network on the hotel, you leave. I get the first, I can place you at that period of time, or at that location for that period of time. So where'd you go pulls information from the registry. It also looks for WLAN autoconfig logs and your network diagnostics. This is pretty cool. On a Windows system, if you've ever had that, you're trying to connect somewhere and you're not getting there, and then it says, would you like to diagnose your network connection? And you click the Diagnose My Network Connection button. One of the things it does during the diagnosis process is it turns on your wireless network card and it records all of the wireless networks that are within range of you at that point in time, along with the signal strength to those. So I can take that information, I can submit that to a Google API, and I can, well, you were here when you clicked the wireless diagnosis information and put you at that location. Also, as you saw in the SRUM, right, you ran netcat at this date and time, and at that time you were running over this wireless network. So those wireless networks are also recorded in the SRUM. We can place you at locations at that point in time. So it pulls information from all of these different things, and it builds a little map, puts little pins on there. It says the laptop was here, laptop was here, laptop was here. And again, you can get this at my GitHub page, where'd you go? And the last thing I'll mention is I'm happy to support these tools, right? If I didn't want people to use them, then I wouldn't have tricked you into coming to this talk and told you all about them, right? So I hope that you'll download these tools and use them for free. But a real passion is not just giving you tools, but also teaching you how to write your own tools. And if you're interested in that, I do have my course, SANS SEC 573, which is Automating Information Security with Python. And I'm happy to teach you to build your own tools like this or modify these tools as you're doing it. Okay? That's all I have. Any questions? Do I have any questions? Yep.
For your free tool,
Mm-hmm.
how does it work with non-English or non-American or UK English? Say for India, recently at work had an alert come up from AWS guard duty that said, hey, we think this is a DGA. At the end of the result, it was an Indian blogger who was hername.com or .info or whatever it was, but just the way that Indian spelling works versus US spelling,
Yeah.
Amazon tagged it as a DGA to make India appear.
Yeah, that's a great question. So the question, if you couldn't hear it, was how does freak.py work for non-English characters or things that, so the table that comes with it, freak table or freak 2018. I built that table by just feeding it text from, I fed it the complete works of Charles Dickens, Little Women, War and Peace, Herman Melville's Moby Dick, and several other literaries. I also fed it a bunch of technical documents and debates between Al Gore and George Bush, and a bunch of just, if I could find a big bunch of people with lots of words, fed it in there. And so the frequency table is based upon that. But the frequency table also has the ability to create your own. So if you have Mandarin, right, and it's just based upon this character follows this character. Right? So if you have a bunch of Mandarin, and you feed it Mandarin, it will learn that this character follows this character, and it does have Unicode support, or UTF-8 character support. So you feed it these things. Now the tables that comes with this tool is just English, but you can build any table that you want to and doing it. I have seen people using freak tables for finding other things. So one of the things that I think was pretty cool is, like Metasploit generates random host names. When you get popped by Metasploit or other pieces of command and control backdoors, they generate executables, random exe names, and then they run those processes. So I've seen people build frequency tables that you take all of the names of the standard executables that comes on Windows, and you build a frequency table for those names. And then you analyze every executable on your network with freak.py. I've seen people build some frequency tables for certificate names. Right? So the kind of names that you would see inside of SSL certs and things like that, and identify things that just don't conform to standard names that we have on there. So you can build any tables that you want to with freak.py, and it will measure the probability of character following character. It's a good question. Thanks. Other questions? Yep.
Hey Mark, so the domain, your domain stats.
Mm-hmm.
How does it work against shortened URLs? So if I have like a Go,
Right.
will it work against them?
Yeah, so the question is, how does domain stats work against shortened domains? It depends upon where you're feeding it from, right? So ultimately, you're going to have something on your network, like an event management platform or Zeek or something else, that takes a domain name and sends it off to domain stats. Now, with domain name shorteners, right, you're going to make a request for the domain name, and then you'll get back the actual host name and then send a second request off to that actual host name where you get redirected to it. So that's going to have both of those requests. And if you're just monitoring all DNS traffic, you get both of those. But I would imagine that there's maybe a way to just get one or the other. I don't know how I'd do that, but.
Probably just look for a list of known shortcuts.
Yeah, you could do some kind of filtering where you look for a list of known filters and ignore those. But once you see them, they're gone anyway. Okay. Any other questions? All right. Well, I hope you find these tools useful. If there's some additional feature or something, this would be useful to me if you just did this one other thing, then just send me an email, and I'll invite you to come to my class, and then I'll teach you how to do that. No. No, that's it. All right, thank you.